And next speaker, we go back to market-related studies. So it would be Ian Baring-Gould, and he's the Technology Deployment Manager for Wind and Water in NREL. And his presentation will be about the distributed wind energy future study, a look at the market potentials in the US. And yes, we can see your screen.
Great. So hello, everybody. Great to be here from afar. Rocky, I love your background. That's much better than mine. I love the idea of being actually someplace where you're working on turbines. That's great.
Thank you.
So I'm going to talk about a recent study that was released out of NREL. I'm talking about it, but want to highlight really the team, the large team of people that actually pulled all this together. And so I'm being the spokesman here, partially because some of the other people on the team couldn't make the time of the call. But I also oversee the project and am really familiar with it. So happy to talk about it. But again, it's a large team effort and includes getting data and stuff like that from Alice and others. So it's really an effort by the US Department of Energy to support better understanding of what distributed wind could look like in the country. It's focused on the US, but I think a lot of the findings that we talk about here, and we can have a little conversation about this afterwards, is really applicable to Europe, especially given the context that Europe sees itself in with really needing to up the deployment of renewables. What this study really showed in the US was the kind of the extreme market potential for the technology as we see it now, especially in kind of environments where you have fairer policy compared to solar technologies. And I think following a little bit on Rocky's presentation is important. What we're certainly seeing in the United States is that the cost of distributed wind across the scales from as small as 3 kilowatts and then certainly up to the megawatt scale is less expensive than rooftop solar. And so we're not looking to replace rooftop solar. You definitely want to do that. But what the models that we're going to look at in a second, but also what we're kind of seeing in the market space is if you want to go beyond rooftop solar, and if you have land and you have a reasonable wind resource, then it makes a whole lot of economic sense to be looking at wind and solar applications. And in areas where you really need to reduce imported energy, which is certainly the case in Europe right now, it becomes a very attractive market space. So without further ado, I'll jump into slides. Assuming I can get them to work. Okay, so I've really kind of talked about this already. But the purpose of the study was to really look at the economic opportunities for distributed wind across the scales from kilowatt to megawatt. And we were looking at today and then in 2035. And part of that was because of the goal that the current administration has put out there to have a decarbonized electricity system by 2035. And so that's why we picked that date. And our approach, and I'll talk through this a little bit more, was to use really specific data of what we call parcels here, but it's basically taxable entities and the land associated with taxable entities, and using a series of tools that we have to look at the economic potential for developing distributed wind on all of these little parcels of land around the country, and then looking at what that means from an economic potential standpoint. So just really quickly, we talk about distributed wind in slightly different terms than our European colleagues. And so we are looking at systems from the residential scale all the way up to large multi-megawatt turbines installed in small applications. So we kind of define it as 10 megawatts, so a 10 megawatt system, which is what you would install on your average kind of distribution line at a distribution voltage. And then if you go above that, then you're talking about large scale wind facilities, both onshore and offshore. In our studies, we also break them up between behind the meter applications. And so that is behind your electrical meter. So if you're at a school and the turbine is installed there and you're running your meter backwards, or you're dissipating local load, your load at a retail or wholesale rate, whatever you're paying, that's a different economic question than if you're in front of the meter, which means you're selling into a wholesale power market. And so that economics changes drastically in regards to the economics of your project, which is pretty straightforward. So the modeling framework that we developed, the DGen tool, and we use the DWind for the wind version of it, is a relatively simple tool set that looks at the wind resource, what we have here in B up in the upper right. It looks at the kind of average electricity consumption for different types of uses. So if you're a commercial use, an industrial use, or a residential use, so how much energy you use, and that's down there in the lower left. And this is a map of Colorado. And so we look at it kind of on a county basis or something of that nature. And then on the lower right is where you could develop a wind turbine. And so we look at these parcels, this kind of group of lands, or if you're an industrial complex or a house, we look at how big that space is, and then you say, where are the buildings on that space? And how far can you be from property lines? And we kind of zero in on that space and say, how big a wind turbine can we put on this little piece of land to be able to assess what the potential is. And then if you're in a behind the meter application, we look at what your load is. So what your expected load is, and you can't go above your expected load because you're behind the meter. And if you're front of the meter, then you sell it to the grid. And so it's how big a turbine can you put on this piece of property? And then what are the economics of selling that power to consumers? So it looks at the whole United States, looking at these kind of core factors, and then determines what is the economic viability of deploying wind in that area. And so the key messages of the report are what we see here, and I'll go into them in a little bit more detail. But it says, looking at distributed wind, and again, this is for front of the meter and behind the meter, up to from very small systems all the way up to around 10 megawatts, there is the current economic potential to deploy about 1.4 or 1,400 gigawatts of wind in the United States. So those are the economically viable projects here in the US today, which is obviously a huge number, and very different than the levels of deployment that we're seeing from Alice's study just a little bit ago. And then with favorable regulatory and policy direction, distributed wind energy can be even more profitable from a development standpoint. And Alice didn't really delve into this, but the new policy that was just put in place here in the United States really opens up this regulatory framework for distributed wind, both at federal sites, but then also in behind and front of the meter applications. And that wind technology can really supply all of these loads across the nation if we choose to use it to get to some of our climate goals. So really looking at the methodology, as I've talked about, we use parcels, so this little piece of land, and then we look at it, the wind resource over time, and we look at the potential for siting. So we look at it by technology, distributed wind and distributed solar, and how those work, and then the application, whether it's front of the meter and behind the meter. And again, those have different economics and different requirements. And so you really look at it from this kind of development perspective, and you can see a little picture there down in the bottom to show you the parcels that we're talking about. So that's a piece of land at the intersection of two highways. You can see the houses down there in the lower left, and it says you have the houses down there, you have to be away from the property line. There's one place to put a turbine kind of in there, that circle that you see, and how big a turbine could you put there? And then what is the economic potential of doing that? So you look at the parcel, and we can look at all of these parcels across the United States. What size of a system could you install? Is it a 5 kilowatt turbine or a 1.5 megawatt turbine? what is the resource that is there, so you know where you can put it, you know how big it can be, how much power you're going to generate from it. You look at this valuation, so is it going to be behind the meter, front of the meter? What are the economics of that? How much does power cost in your area, whether you're behind the meter, or what's the wholesale rate that you can sell into if you're front of the meter? And then you calculate this capex of how much is it going to, what is the power that comes out of your wind turbine, and then you can compare that to the costs. And we do this again for millions of parcels across the United States. And what we end up doing is developing this supply curve, which is, you have to kind of twist your brain a little bit to think about it, but it says how many gigawatts could you install at different prices. So if your small wind turbine is $8,000 per kilowatt, then you won't be able to install very many of them. And you can see the available sites in gigawatts is pretty small. But if you can get your turbine down to $2,000 per kilowatt, then there's lots of potential out there. And so depending on what your price threshold is, where you are in the market space, you determine how big your potential market is across the country. So obviously, the lower per kilowatt hour you get, the bigger your market space is. Okay, so we looked at a bunch of different studies, and all of these is in the report that I'll point you to at the end. But we looked at this kind of baseline in 2022 and then 2035, and then looked at a whole bunch of different case studies around that. Optimistic policy, siting is a big issue. So where can you put it? How far away do you have to be away from property lines? We looked at cost, financing, the ITC, which is the tax credits here in the United States, and then the value for distributed resources. So whether you get high value for offsetting local load, or whether you get low value for offsetting local load. And so all of these kind of assessments we looked at throughout the study. And what you do is you get a bunch of these curves that I talked about that said, again, on this axis, depending on how low the cost is of your turbine, how much market potential you have for, in this case, behind the meter applications. And then we have similar curves for front of the meters. So in the study and the numbers that are kind of in the report, we use this $5,600, which is the kind of the current average price for distributed wind turbines. And again, we have these by size and all this kind of stuff, but it's that kind of number. But you can see here in the US market context, if you're a turbine manufacturer and you can say, I can get to $3,000 per kilowatt, well, then you get a sense of how big your market is, depending on these different cases that we're looking at here. We have, these are the numbers based on that 5,600. So in the baseline, it's almost a terawatt of wind capacity and behind the meter applications. And then looking at all of these different case studies, what it looks like as we go into the future. But again, very high numbers, which means there is a great deal of economic potential for behind the meter applications in the United States. Similar thing for front of the meter, so a different cost structure. These tend to be larger projects, and so the cost structure is lower. You have to get your turbines to a lower cost to be able to make them cost effective in these types of markets. And the market size is at this point smaller because wholesale power prices are relatively low in the United States. And so you have to be able to get your turbines to a pretty low cost to be able to have them kind of economically viable in the US market. Now, clearly things like improved ITC, the investment tax credit, which has passed for a bunch of these projects, relaxed siting and things of that nature, getting down to this optimistic deployment level, shows over 6 terawatts of available capacity in 2035. So if I'm looking at that from the perspective of what do I need to do to be able to get lots more wind installed in my country, US in this case, but all of your countries in your case, what are the types of steps that I need to do to see distributed wind be a real major market player? You can see these here. It's relaxed siting, kind of lowering the cost, whether you do that through technology innovation or some sort of subsidy mechanism. But there's a lot of land here, at least in the United States, and I would say in Europe as well, to be able to deploy these types of projects in front or behind the meter applications. And this gives you kind of a sense of where in the country, going back to those kind of visual maps of what are the cost thresholds that you have to get to be able to deploy, in this case, front of the meter applications across the United States. So again, you have to twist your brain a little bit here. This is front of the meter. So if you can get down below $1,500 per kilowatt, there's a good amount of this kind of center part of the country where there's viable wind and enough locations to deploy distributed wind technologies. Clearly, as you get down to lower costs, then the areas that have lower wind resources, lower power costs, you have to get to a lower turbine price to be able to get to those markets, which you see in the West, in the New England, and down in the South. Similar for front of the meter, but looking out to 2035. Again, similar things. You have to get to a pretty low price to be able to get into those market areas. Behind the meter is it is a very different market. So in this is showing here in a lot of areas of the United States, again, if you can get below this $5,000, you have lots of market potential here in the US. And in places like California, the kind of those dark areas, your turbine is economic at $13,000 per kilowatt hour. There's lots of available areas where you could deploy distributed wind in behind the meter applications in those parts of the country. And similar in 2035. So almost the whole country is economically viable if you can get down into this $3 to $5 per kilowatt, or $1,000 per kilowatt, sorry, which is where, as Rocky was just talking about, is not out of the realm for most distributed wind, small and medium scale technologies. We do look at this by state, and again, this goes into different market spaces, again in the report, but I won't spend much time because we don't have much time. But agricultural land is a huge opportunity for both front and behind the meter, with a number of great states, or a number of states that have great market potential. We also look at commercial and industrial, so smaller market spaces, but you can see here for front of the meter, lots of market potential for these types of applications. Residential sector, again, lots of gigawatts in different states, depending on certain rates. All of this is really to point to that you can get to really specific information within a national context of where it's economically viable to develop distributed wind projects across the different scales. We also did some looking at energy equity, so looking at disadvantaged communities to see where you could deploy distributed wind that could help address stuff like energy burden with lower electricity costs and increase electricity reliability. And so we were able, again, because all of this data is geo-referenced, we can get pretty specific in regards to, from a policy perspective, which parts of the country distributed wind could play a really active role in addressing energy needs of disadvantaged populations. And this is looking at behind the meter applications. So again, lots of the country has good opportunities for distributed energy. So really going into conclusions here, and again, encourage you, if this is kind of interesting, to really look through the report. Even though it's focused on the US market, I think anybody in any place across the world could take the gems out of this report and apply it to your own country, because I think they are basically universally applicable. So economic potential of distributed wind is really strong. And the idea that if we were trying to get to a clean power system in the United States or in Europe, that there is tons of distributed wind that is economically viable today, that could be deployed today, let alone as we go towards 2035. And I would hazard that given the cost of natural gas in Europe, it would blow away the cost in the United States. The economic potential of distributed wind in Europe is probably astronomical given your kind of current costs of power. Policy is really critical. So in this case, we're talking about an investment tax credit that lowers the cost of wind. But it comes down to cost. You lower the cost of the technology, it becomes more economically viable. And just getting parity to solar from a cost perspective opens up the market to a huge degree. I've already talked about it today, at least in the United States. The economics today make tons of sense in comparison to photovoltaics or any technology, let alone as we go forwards and the technology gets better. And generally speaking, the costs of power go up. Let's see. Agricultural lands, at least in the United States, have huge potential for behind and front of the meter applications. And so that's a key market area if you're going to kind of target where you want to look at deploying wind. Agricultural areas have huge potential to be able to engage. And that's from small scale all the way up to large scale. So with that, I'll conclude and take questions that people have. Again, the full report, this presentation or version of this presentation, as well as another video of one of the people, Kevin McCabe, who is the lead author of the paper that he gave about a month and a half ago, are available on the web. And if you just type distributed wind futures study into your browser, it'll come up really quickly. So that's the easiest way to find it. Just type in distributed wind futures study and you'll get all of this. So happy to take any questions.
Thank you very much. And of course, we can include the material, the report here in the proceedings of the conference. So
yep,
yeah,
definitely.
No problem with that. Yeah, questions? Yeah, we have one question here from physical audience.
I need your help from NREL. We are looking to diversify the portfolio of education and Folkecenter to include green hydrogen. And I have seen the site of NREL. You have been starting since 30 years, having educational program. Can we get more material from NREL on that? Yeah, because you are heading for low carbon economy with renewable and green hydrogen.
Yeah, no, that's definitely the case. We've got a lot of material. So yeah, certainly don't hesitate to reach out. And we're producing lots of documentation on an ongoing basis around the question of green hydrogen and how you deploy that to get to low carbon futures. Yeah, without question.
Meaning capacity building, education.
Yep.
Is what we are looking for your help. And I know that NREL is well a pioneer on that.
Yeah, no, I know we're doing work on it. I can't point you specifically, but we can certainly connect you with the folks at NREL that are working on within the hydrogen program office here at NREL.
Then you can send it to Daniela and then we can follow up. Thank you.
Okay.
Thanks.
Yep.
Other questions from the audience? Was it Fritz? Was that a question up? No.
Okay. Ian, very nice presentation. Perhaps a strange question. The NREL has the NREL a similar institute somewhere in Europe?
So there is not an institute, not an NREL institute in Europe. We do have NREL employees in Europe, if that's what you're getting at. But NREL doesn't have any kind of presence in Europe at this point.
No, that's
Colorado. Yeah.
Yeah.
If we tilt this study like this up to European level, which institute in Europe could do such a study?
Oh, okay. So So that's a good question. The tool itself is available on so it's publicly available, so anybody can download it. Now, being able to use the tool once you've downloaded it is a much different question. I mean, any of the institutes, the Folkecenter could do it, DTU could do it, Fraunhofer could do it. I mean, I think you would have to invest a bit of time and energy. I mean, conceptually, NREL could do it for you. It's not tons if you have the data, and that's the key thing. So you have to have the data, and you need to have the parcel data, so the land and satellite imagery of that. That's pretty straightforward. You have to have wind resource, and you have to have rates. The rates are probably might be readily available in Europe for consumer and wholesale prices, and usually there would be certainly some time to kind of digitize that in the right fashion if it's not digitized already. But then basically any good research institute or academic institution could run the study, and it's probably not very expensive. I mean, probably $200,000, $300,000 euro in that neighborhood. You could take what we have done with the future study and repeat it for all of Europe pretty cleanly.
Yesterday, Dorte Fouquet had a presentation, and we can easily we can ask for a subsidy below 60,000 euros.
Mm-hmm.
Is it more? Then we have to wait for a call from the European Union. So you said 200,000, 300,000. Okay, that's it. That's what I'm.
But that could also be as I mean, it doesn't have to be a whole study at once. It can be as sections, for that matter. If the limitation is 60,000, then you do it for 60,000. I would say.
Yeah, no, that's exactly what I was going to think. I would say, put in something that says NREL has developed this tool. The U.S. Department of Energy has developed this tool, DGen, and the DWind model. And for $60,000, it's open, it's publicly accessible. They've got it on GitHub. For $60,000, we want to take it, pull it to Europe. We want to assess European data to be able to run DGen in Europe or parts of Europe. And we'll do the data assessment to understand what it will take to be able to do that. And maybe the result is a proposal or a study, kind of a white paper on this is what it would take to be able to do this type of very detailed assessment of solar, wind, and storage, because the storage is part of this, deployments within Europe to understand the availability of distributed technologies to address near-term European energy needs. Yeah, and 60,000 would get you really far in understanding what it would really cost.
Thank you. Mm-hmm. So I guess we should start moving towards the last speaker, because we are running a little late. Then, of course, when we are over all this, then the floor is still open. So if people want to further discuss, no problem. But yeah.